Alright, time for another DraftPhysics.com, DebatePhysics.com also, video presentation. So, the evil, ugly, smelly Dispar lab guy, has done another video where he's claiming this 1.4 thing. Now, he has made an obvious, kind of a simple technical error. I mean, it's a simple experiment, and he made a really simple mistake in the assumptions made in doing the experiment. And frankly, if he does it the right way, it will prove momentum, not kinetic energy. And we'll demonstrate it anyway, let's just say. I mean, there's lots of flaws in the experiment. He's banging something into a cardboard carton. The carton is flexible. Lots of things are not good. But there's a more elemental and fundamental mistake in the logic of the video. Now, these are the people that make fun and mock the idea of modeling things and drawing them first and explaining how they might work, the system. They all think that's a waste of time. It's clear they pay the price for that, which is making all these errors and mistakes. Because they really don't pay any attention to the details. So I did leave a comment yesterday. Dispar has done a video, simple kinetic energy experiment, where he's done another scientific experiment, in quotes, just because, this is just a joke. This is what science is supposed to be. These are people trying to prove me wrong. They're not trying to prove anything right, and they're certainly not trying to defend physics, They're just haters who, think, that there's some advantage to be gained in trying to tarnish, my integrity or reputation. Anyway, that just happens to prove kinetic energy, or the 1.4 thing. So, again, this 1.4 thing, you don't really see it in physics books anywhere, because it just creates one of these duality problems where they're just going to have to say, oh well, I don't have an explanation. I mean, the fact is that any time, as I pointed out many times, you transfer energy between light objects and heavy objects, you're going to screw up either the kinetic energy or the momentum. That is, you're going to have a screw up where you're going to have a catastrophic lack of conservation. And you really can't do that. I mean, it breaks physics. So one of them has to be right and one of them has to be wrong, pretty much. You really don't have a choice. The experiment, once again, has a substantial logical theoretical flaw. So again, it's they just don't care about the theory of anything. And so I said, let's see how long it takes them to find it and acknowledge it. So far in a day, they haven't been able to do it. So let's see how long it takes for them to understand the physics, understand, oh yeah, that experiment really isn't really saying what you think it's saying, because you really have, you've just ignored, like I could draw a smiley face on the board. Maybe that would give you a hint. Curved line, I could curved line, but yeah, so far, no. They don't have the brains, they don't have the knowledge, they don't have the understanding of physics, they don't have enough of any of that stuff to actually do this stuff with any kind of credibility. So they keep making claims that really the evidence doesn't really support. The evidence well interpreted or reasonably interpreted. And certainly they have, again, no explanation for what they're claiming to be true, the creation of free momentum in experiments, and the destruction of momentum in experiments. Two things that pretty much all the old physicists would say you can't do. Alright, then there's another experiment by the Falwell asshole. I didn't see this one. This one happened earlier, I guess. A little bit earlier. And again, it's stupid. Yeah, I mean, the flaw in the logic is just so obvious. And it's like, well, and they're so arrogant, so proud of themselves, and so full of themselves. Oh, look what we've done. We're proving something kind of ludicrous and preposterous, And and they're doing it with these cheaty little experiments. And and it's almost like you got to say that, well, how can they roll snake eyes every time, right? Well, they're just filming the part where they roll the snake eyes. So they do the experiment lots of ways. It doesn't work, and they find a way to do it where it comes out their way, and then they emphasize that. So I won't bother playing it. I'll just describe, because it's just a mess, the way he videos everything. But anyway, and he makes all these assumptions about what the speeds are, and he didn't measure any of these velocities, didn't do any of this crap. So it's a really poor experiment in terms of performance alone. But again, just so logically flawed. So this one I will explain. Okay. They obviously, nobody in their comments, he's got 13 comments now. 13 comments. We'll see if any of them point out the obvious defect. Okay. Obvious, substantial defect in the experiment. And they all just ignore it. Alright. So, here's the experiment's really simple, which is nice. These rolling things and hitting things is nice experiments, but so the first thing they don't pay any attention to is this idea of how you launch something with a spring. So I guess I'll do that again. Draw it, because drawing does work. Okay, so you can sort of explain that, yeah, a regular spring or a rubber band is a nice idea, okay, in terms of it can store energy fairly reliably. And then you just have to have a mechanism for connecting your spring to the object you want to move, and you have to just make sure that it's solidly connected to a fulcrum, a base. And so in theory, you should be able to put energy in and get the energy back out again. Now, what they keep using are these springs that have these mechanical parts to them, all right, that that create some sort of thing they can catch on and something. So this whole part ends up being part of what the spring has to move. So you can sort of understand, when you put an object in front of it, what is the spring seeing? See, this is where drawing helps. See, what does the spring is sitting here, what does it see? Okay, from its perspective, what's happening to the spring? Okay, and you can understand that, yes, what the spring sees, okay, is this. It sees the bar, it sees the plastic thing here, it sees the brown thing, it sees this whole mass. And you can sort of understand that when it's going to push, it's not going to, this isn't going to stop for some reason. So all the energy that the spring has to use to push this part, all of that energy is lost from the experiment. You're going to lose every bit. And then you can also understand that if you're moving that thing twice the velocity, okay, that's a lot of velocity, twice the velocity, that obviously that's twice, okay, you have to add up that hunk of momentum. So when you're trying to push it twice as fast, one of the problems might be, is that, yes, you're losing twice as much momentum to this parasitic object, this object that's stealing energy. So it's using the spring's energy to give it momentum. It's not going to give it to the object. It's going to keep it. It's going to keep going, just like the round thing's going to keep going. This thing's going to keep going. It's going to take the energy. So there's clearly a huge difference between the complete, how much it's going to sacrifice to the thing it's moving. And then you can understand, if this is a 2 mass and I put a 1 mass in front of it, right, and go twice the velocity, I'm even further increasing the disproportion. That is, the percentage of the energy that will be in this thing versus the percentage in here is going to go up. So this is the same thing I described about what I didn't know about levers, but I discovered about levers partially through drawing it and trying to understand how it works. Okay, so and that process I've learned, oh yeah, the whole, what is the lever actually seeing? What is this? What is, I have a lever and I put a rubber band on here. What's it really seeing? Well, it's seeing the mass of the lever, and then it sees whatever weight you put on it. But it has to move this. That's part of the experiment now. So anytime you use a launching device that has some crap that you have to move, that's probably not ideal. it's probably better to have some structure that doesn't move, that's confining the spring or holding the spring or locking the spring or doing any of this stuff to the spring. Better to have that as this external structure, not as an internal structure. So that's just physics. So obviously there is a certain disadvantage to lighter things, pushing lighter things, because your pushing mechanism is going to steal some of the energy. Even the spring itself, you have to calculate. If you're using a kind of a spring that has any kind of mass, the spring itself is going to move. And when it's pushing the object, it's not going to give it all of its energy. It's going to be going the same speed as the object. So when the object leaves, the spring's still going to be going almost the same speed. So it's stealing some of the momentum, some of the force. All right, so second, okay. So what he's doing, he's using a little spring launcher to launch two objects, okay. We'll just say a 2 mass and a 1 mass. And the key is they're the same size, okay. So one of them is tall, okay, the 2, and one of them is short, the 1, okay. But they have the same surface area contact. Their contact with the surface is exactly the same. So even though one weighs twice as much, its density, the amount of mass per unit of surface area contact with the ground is twice. I mean, is twice as high, in the sense that it's twice as much mass per unit of contact. So anyway, he does this experiment with presumably the same force launching, right? But except he's using a launcher again that has parts in it. Okay, so it's not going to be fair. He's not measuring their actual velocities at liftoff, so to speak. Okay, and so what he's doing is just taking little flat things, okay, and pushing them on a frictionless surface. All right, and seeing how far they go. And so he's doing the same thing that Brozo's done. I've even done experiments like this, and we know from experience that rolling things is a little tricky. And in this case, it's going to be another tricky thing, because you don't have angular momentum. You don't have lots of other ways that you have friction on axles. This is just going to be raw friction with a surface. So he does the experiment, and the outcome is, the 1 mass goes this distance, and the 2 mass goes the 1 mass only goes 1.4 further than the 2 mass. So the 2 mass goes 1 distance, and this goes 1.4, or something close to it. So once again, attempting to say that somehow the lighter thing doesn't have twice the energy at twice the velocity. And again, it's just assumption that it has twice the velocity. Again, the spring launcher has a dubious capacity to produce that twice the velocity. So it's probably a little less than twice the velocity. And clearly in this case, okay, the 2 mass has an advantage because it has more mass on less surface. That is, if I'd made the 2 mass out of 2 1s, one can figure that, oh, well, that's twice the surface area, twice the contact with the ground. So it's, much more contact with the ground. So he should have done the experiment with the same surface area per mass contact with the ground, and then the results would have been more predictably 2. Probably something like 1.8 because of these other flaws. But clearly the 2 mass went further than it should have, merely because it was taking advantage of the fact that it was making less contact with the ground. And if per ounce or per unit of mass it had the same surface area hitting the ground, it's pretty clear. So I guess I would just say, what would your predictions be? Okay, you pile of you thems. What is your prediction? Do you think you're going to get 1.4 if you have the same surface area contact with the ground proportional to the mass? So if the contact is proportional to the mass, do you actually think you're going to get the same results? Yeah, I think you know better. So, bogus experiment. for kind of easy to demonstrate reasons. And again, they're just going to announce their victory over momentum with this nonsense. Again, I went over the De Chardonnay. I haven't gotten a single comment, a single rational explanation about how anything I said about my analysis of denting clay, denting, not penetrating, denting clay with round objects, how it can't make theoretical sense that it's a fair test just because of the round surface. It's not a linear fair test, and this isn't a linear fair test because you're obviously giving the heavier mass a huge advantage by obliging it to have less contact with the surface, and the surface is what's taking the energy. Alright, so let's read the crappy comments. And such. I guess I could probably make that a little bigger. Not that it really matters. So, Dispar says, thanks for doing this, Michael. Love your launcher. So again, why would you like launchers that have a bunch of moving parts in them? Let's say it again. We have another variant of equal energy input into a mass. So we don't know that they're equal energy. So this guy says, Falwell guy says he has timing gates now. So I don't know if he, feels like using them. Maybe he should use them to test his launcher and see if he actually did launch at twice the velocity. And half mass, and coincidentally, so I'm arguing no, it's not a coincidence, okay? All of this crap is not a coincidence, okay? And clearly some of these experiments are done eccentrically, and you can almost argue that why are they doing it like Brozo did his clay experiment where the lump of clay is this big and he only compressed this little tiny surface. Why would somebody do that? Why would they do the experiment with 90% more clay than you need? Why would somebody do that? I mean, when they want the experiment to show half here and a big mark, so you can see a big, huge difference, not a trillionth of a millimeter difference. No, a big, giant difference, a nice visual difference. Why wouldn't you do the experiment that way? Because it doesn't work. That's why. Okay. Just amazing. Coincidentally, the ratio is around 1.4 again. Okay. But as has been proven by drawings on a famous whiteboard. So this is this is their attitude. They really think this isn't physics. Me drawing on this board, explaining experiments, explaining the force diagrams. They don't think force diagrams are a fundamental part of physics. I mean, it's just so elemental. Maxwell's drawings, complete waste of time. Amazing. Just an amazing asshole attitude. Okay, only bad experiments can produce 1.4 results. I'm just saying, look, one of them is real and one of them is false, okay? I'm going on the side of Galileo, Descartes, and Newton, who did tons and tons of experiments, even Huygens. I don't think Huygens actually jumped on this bandwagon, frankly. So this really is Leibniz's theory and no one else's until De Chardonnay showed up. So that's, you're defending the long outsider where most of the scientific minds couldn't see what you think is so obvious. All right. This is in fact the very nature. So again, we know this experiment doesn't show a fact, okay? So, way off again of bad experiments. This is in fact the very nature of bad experiments. Well, I'm just saying now, obviously the experiment has a huge theoretical flaw in the sense that you're not making a fair comparison. I mean, you have physically broken the leg of one of the horses here, so to speak. I mean, you are cheating, aren't you? I mean, to say the two objects are in the same condition when one of them is going to be rubbing on twice as much surface as the other one per mass is hardly a fair fight. Imbeciles. They're too stupid to draw pictures. They're too stupid to do a force diagram, but they don't know any physics. they can't explain to me, okay, or to maybe you. Maybe you're smart enough to think that, well, that argument, like, 1,000 atoms going 1 mile an hour really should equal one atom going 1,000 miles an hour, and the one atom going 1,000 miles an hour really shouldn't be called 1,000 times more powerful, because it really isn't. Come on, that doesn't make any sense. It'd be nice if they could draw that and show somehow how the one atom going 1,000 miles an hour has 1,000 times more power, more pushing power than the 1,000 atoms going 1 mile an hour. Draw me the picture. Okay, let's see. No worries for doing this. Well, that makes no sense. I tried to do it as badly as I could, and that's, you're sort of demonstrating. Anyway, to guarantee the default bad experiment 1.4 ratio outcome. Cough, cough. So they're just making a joke, and the experiment is fundamentally got a gigantic logical flaw in it, and they just couldn't care less. I will do a better version. Yeah, do the version where the two objects have the same mass to surface area ratio. Since you're using the surface to pull away the energy, they should have the same ratios. Okay, when I have more opportunity and throw a quarter mass into the mix. I'm overwhelmed by the love the launcher is receiving. LOL. So again, another joke. So this is after Dispar learned for himself that his little plastic launcher with all the fucking parts in it wasn't really as good as just a plain rubber band. And one with a quick release, by the way. I mean, just, they're such pathetic, lying, deceiving creeps. Thank you, my friend. Have a good one. Emoticons. Alright, so a Brozo comment. Ought to be, yeah, kind of short for him. Alright, wow, great to see nature. So again, they're going to argue that there's something that makes natural sense. So, this is like, to me, the voltage argument. So this guy used to be a Sparky of some kind. He knew something about electricity. And, anybody who's played with electricity, it's very unintuitive to have some notion that I would square the velocity. That somehow the amperage and the velocity wouldn't be even players in the game of watts, and that somehow, amplifying the voltage would somehow make something have more watts just by magic, and I wouldn't have to change the amperage at all. I mean, it's just, it doesn't work as a theory. It doesn't make any sense. It doesn't work in just simple things like, again, hydraulics and water lines and water pressure. None of this kinetic energy theory is real in any of those circumstances. And again, he's saying this is how nature works, though. Nature does this thing. Alright, couldn't have been much better, really. So, just there's nothing to say. Okay, when you question whether the spring might be getting worn out, I have always wondered, kind of half suspected after watching a particular YouTube video on bows and arrows, whether the speed with which we reload and relaunch doesn't perhaps affect the energy available from the spring just a little. Yeah, it would be just a little, so who cares? I mean, the clay experiments, its temperature is probably a lot more important, at least for some clay. This is a moldable clay, and it's, temperature means a 30 degrees difference in temperature, and this stuff gets a lot softer. Alright. Let's see. The way that shows proves it does affect the energy available to a bow. In other words, when they reload the bow faster and release it without delay, they achieve more energy, and they explain this as being something to do with the heat generated when loading the bow. So no one's loading bows here, frankly. And even rubber bands, they do make some temperature transitions, but again, we're talking about the thing we're launching is not much lighter, it's much heavier. the bow is heavier than the things it's launching usually. Okay, having time to dissipate if they delayed releasing. So what is this? Well, I'm just so surprised. So this is more experiments he did that we never saw. Okay, so I tried that on my setup at the time, a spring release type thing, and it didn't seem to improve the results if I released it as quick as possible, hoping not to let the spring cool down. Not that I could detect the heat from the spring anyway, so it's probably not significant. Again, the difference is sort of obvious. Bows and arrows are gigantic, okay, and the thing you're shooting is relatively light. So it may have just been a coincidence, but anyways, wondered. Can't remember the name of the channel that was on. The guy named Justin, I vaguely recall. So just how fascinating it's not. Sorry, this was a real clunker. Who did a lot of slow-mo type videos touring rocket factories, etc. Anyway, nicely done again, Michael, and very nice and distinctly explained too. So again, he didn't explain anything about surface area and contact with the surface. None of that was explained. Alright, thank you, Steve. I was so tired during this filming this that the sound half asleep because I was LOL. And that is how you sound most of the time. I did the explanation a little later when I was slightly more awake. Oh, brother. It's far from perfect. Some readings and measurements were slightly off, but I was too tired to care. So this is how much they really care. It illustrates the point as to why the half mass will never achieve twice the velocity. And again, why won't it? You know, they don't give you a theory of why it can't go twice as fast. They say a word like inertia. So light things are harder to push. That's their theory. It's harder to push a light thing. Does that make sense to you? And it doesn't make any sense to me. Know how many times he tried. So again, they're arguing that you can't make a spring, okay, where you compress it twice as much and then put a half mass in front of it, and the half mass goes something like twice as fast. They're saying that can't happen in this physical reality. Yes, I do think the spring is probably affected in the way you described. It's metal after all, and the heat will change it ever so slightly, giving a little. See, I don't think this is the real problem, frankly. Okay, the spring is going to get hot in both cases. If you just alternate half mass, full mass, half mass, full mass, then they would both be affected the same. I think that Justin just mentioned you might be smarter. Oh, that Smarter Every Day channel just annoys the fuck out of me, so I guess I'll stop reading there. Another day I test the launcher out, firing a quick succession, and so this is the stuff that they think is interesting. So understanding the friction coefficient, not so interesting. Alright, so it was Smarter Every Day. Oh, gross. Speak of the devil, Justin just popped into my feed with a new video where he's doing a talk in front of NASA. Oh yeah. Very interesting. Okay. Let's see. I just listened. Who cares? Okay. None of that's on the subject. So the Walker guy says, nice launcher you have there, Michael. So again, why are these people defending launching devices that, like I said, we've all should be now aware of the fact that any parts that are moving in the device are taking energy from the thing you're trying to give the energy to. And if you move those parts at twice the velocity, that means those parts will have absorbed twice as much of the force. Obviously, the lighter object can't go faster if twice as much of the energy is being stolen, okay, by all the moving parts. So Michael says, it's just a repurposed cardboard door spring bolt mechanism. So it's actually a spring bolt. So let's understand, okay? So it's not even as dumb. I thought it was just dumb. It's metal. Okay, so it's a spring with a piece of metal in front of it that slides. and he's using that to push something else. So the piece of metal could possibly be massive enough to even weigh a quarter of what the lighter mass actually weighed. The lighter mass might weigh only 4 times more than the piece he's using to push it with. So clearly, a very substantial portion of the momentum for the lighter object was consumed by the launcher itself, let alone the whole friction argument. And they can't figure out any of this stuff. Let's see. I did go to the trouble of stripping it down and making a note of the weight of the bolt, which was 10 grams. So I think the lighter mass is 50. So I wasn't that far off. It's actually 20% of the weight of the lighter mass. Amazing. So anyway, as I thought, the added mass would be a bigger effect on the outcome, but didn't seem to. It didn't seem to if you want the results you want, which is to keep the fast things from going too fast. Yeah, if you want to slow the fast thing down, that's a good way to do it. Oh, just priceless. Priceless stupidity. Let's see. The bolt head is rounded, and obviously the probes are too, so it gives a real small point of contact. Well, the whole point is your contact is supposed to be a push, so you're not really supposed to be smacking it. And so having a small point of contact only matters when you're not hitting something, not when and you're trying to get the energy in through a hit. You're not trying to hit the thing you're pushing. You're supposed to push it, not hit it, push it. So it doesn't matter. Full contact would be better because you're trying to push it. You don't want it to reflexively bounce off of the object. You're not trying to create an elastic interaction where you get any kind of reflections or any other kind of crap. Alright, and the bolt keeps it all very rigid and straightforward, giving a nice solid shove in the right direction. So it's not a shove, it's a smack. Alright, and that's not the idea, frankly. That's not the ideal. You want to push it. You want contact to be complete until the velocity, the maximum amount of momentum has been transferred. Okay. I like your new scales, by the way. Good investment. So more blah blah. They were a bargain at a mere $379 with free batteries too. So whatever. Blah blah blah. So that's it. So they didn't talk at all about friction being uneven. It didn't even occur to them, and they celebrated a launching device that has metal parts in it that move. Okay. So I'm just saying, it's really dumb physics. Right on its face, it's really not good science. This is, these are the mistakes amateurs and immatures make. Okay, these are kind of grammar schooly mistakes. Grammar schoolers could probably dissect this and find the mistakes. Alright. Pathetic. Alright, so let's do the Brozo comment on Disbar's experiment. Alright, so I'm not gonna it's pretty easy to figure out geometric argument demonstrating the flaw in the reasoning he used in this experiment. Alright, so, but I'm not going to draw it because as soon as I draw it, frankly, I'll give it away. Okay, the drawing will give away the huge flaw. So if he would have drawn it first, he would have seen the flaw in his reasoning. But he doesn't like drawing. Alright, he thinks whiteboards are a hideous, degrade of the scientific process. Alright, so Falwell says, nice variation Disbar. I've seen a similar thing where they use a wooden block to knock over and replace a mass with a rubber ball. And yeah, that experiment has a similar flaw in it. Okay, that gives quite an interesting outcome. And again, is the argument they're going to make is that somehow you're violating the conservation of momentum, or can these imbeciles understand that clearly when you hit a piece of wood with a metal ball, anvils actually dent? Okay, so that's what I saw in a video, is they actually showed all the little dents that a ball made just bouncing on an anvil, let alone a piece of wood. But rubber balls don't dent wood. Gee, what a surprise. Anyway, great work as always. I've picked up a timer and some light gates and a very reasonable price, so hopefully in the future I can do some more detailed demos. Yes, hopefully you can measure some velocities and see if you actually have the velocities you claim you created. Alright, so the Brozo says, well, I think this is excellent. It completely destroys DS claim from about 3 years ago about bowling balls. So I don't know exactly how it completely destroys the logical argument that basically says, how is it possible that there could be such a huge advantage to using a lighter ball? That is, the 8-pound ball going twice as fast, theoretically, by their theory, knocks down twice as many pins. And yet not one single professional bowler in the history of bowling, okay, has been able to find that advantage. They don't even go to a 14-pound ball or a 12-pound ball or a 10-pound ball and get a, which is still a substantial increase. It's not twice the pins, but it's still 50% more pins at 10 pounds, at 12 pounds. It's 50% more pins at 12 pounds. You could argue. I mean, too silly. I've tried to test this claim with several bottles of water acting as pins. So this moron did this crappy experiment years ago where he's rolling these big giant wheels that he caused to roll by pushing them with some sort of gravity thing that was really stupid. But anyway, he might have rolled some of them too, just by hand, into some sort of like little thermoses or some kind of little standing up things, whatever the hell it was. Now, first off, we know that rolling is a huge disadvantage for the heavy thing. So the heavy thing has a huge disadvantage when it comes to rolling. Alright, it's going to lose energy a lot faster. Alright, anyway. Rolling a large wheels of 2 foot recording tape. It made a controlled glancing blow against each of the bottles in a line, right? And so one of them had already lost more than half of its velocity. I didn't measure the velocities right before they're hitting pins. None of that took place. Alright. To see how many would get knocked over and the real blah blah. You can just imagine. Well, anyway, it was just a terrible experiment. Just logically terrible, ugly, filmed poorly, the whole thing. Just really stupid. Alright. So he's going to waste all this time trying to defend an experiment that's just really a piece of shit. Okay. The heavier, slower one with the same momentum. So again, he says it has the same momentum, yet we have no evidence it did. Failed to knock down any. So he's making an even bolder statement. That somehow the magical kinetic energy theory means it has even more energy. Or something like that. Let's see. All its energy absorbed in the first 2 or 3 slow collisions that weren't enough to knock them over. So again, anyway, we won't bother going into all this, ancient history, but really crappy experiment. Let's see. But your experiment, I don't know whether you could come up with another simple way to demonstrate his related claim. Oh, here. But your experiment is better because it's more controlled and precise. And just theoretically absolute crap. Okay, it's nonsense. So the fact that it theoretically can't give you the answer you're looking for, well, that doesn't matter. Yeah, okay, and we don't actually need to knock down several pins to prove DS wrong. So again, if he does the experiment actually the way he needs to, that is, with an actually hitting the object with one object moving twice as fast, Okay, the lighter object moving twice as fast. If he actually does it the way it should be done, it's going to prove momentum decisively. We already know that because he's getting these fake results with the experiment broken. So this is just like when Gosling did the clay experiments and he had the wrong measurements and he claimed victory. And then he did it with the right measurements and made a video lamenting how something must be wrong because the results aren't coming out my way. And now he's done it again. Okay, he's engineered the experiment another way, where now he's claiming the 1.4 thing. So even though the 1.4 thing isn't the right answer, it's better than the 2-to-1 thing that he really hated. The idea that the half mass going twice the speed has the same force as the full mass going half the speed, that he just, he anything that he can get to it not to come out that way, he's happy. All right. His claim was worded with regard to how many pins a bowling ball could knock down, so I tried to answer the question quite literally. What a pile of shit. It's about how much energy is transferred to the pins, obviously. I mean, you have to add up the total energy. Again, what do you believe in energy conservation or not? I mean, obviously, I guess these people don't believe in energy conservation. So what are you going to add up? The mv squared, or are you going to add up the mv? That's the real question. But it was unnecessary. You demonstrated the same thing. Yeah, and again, what's been demonstrated is that, you take a 5 mass, you crash it into another 5 mass, it loses half of its velocity, and you end up with something that has exactly the same momentum, but it's lost half its kinetic energy, and you don't have a logical explanation for where the kinetic energy went. You can't draw me a picture of where the energy went. You've demonstrated the same thing far more simply. He's demonstrated he's an idiot. He's an ignorant, stupid, shit-talking fuckhead. That's what he's demonstrated. Okay, that he's a disciple of Christ, and he'll sit there and manufacture any kind of fossil you want to prove that humans walked with dinosaurs. Whatever you want to know, he'll make the fossil for it. All right, and simpler is usually better because there's less points of contention. It wasn't as simple as it needed to be, in the sense that you needed the velocity at impact. Okay, it's another clue. Okay, I don't know whether you could come up with another simple way to demonstrate this related claims to be wrong also, whatever that even means, even though we already know he's wrong. So, and again, they know it because mommy says so. Not because it's logical. Alright. Because he also kept challenging us 3 years ago to show me. Show me something really obvious, like it taking 9 times the fuel to go 3 times as fast. So why don't you just show that one? Why don't you show the big one? Go out and find the thing that takes 25 times the fuel to go 5 times faster. Find that object. That'll be your real proof. When you get to that experiment, well, then you're winning. Okay, if you can show something going 5 times faster, doing 25 times the damage, well, then you'll be getting somewhere. The half mass at twice the velocity, lighting more light bulbs. The argument was making more watts. So this is a guy, a Sparky again, who doesn't know the difference between volts and amps. Okay, and doesn't understand that LEDs don't light until they have a minimum voltage. He doesn't know that. Moving more marbles. Let's see. Pumping more water uphill. Lifting more horses with a pulley. Well, I'm just saying, aren't these all experiments that should have already been done? So again, this is the joke, right? You've had 300 years to shore up this theory, and nobody's bothered. And you're saying, well, science is great. I mean, science just tells us the truth. Science is so cool. Amazing. All right. Well, I tried. After about 3 months of no one responding to his challenges. So again, and you haven't responded to them. All right. just wanting to know the answer for myself as much as anything, because in my ignorance. Yeah, and you were ignorant. And is there any point in claiming that we haven't learned something in the last 2 years in arguing all this crap? Learn something about quick releases, and learn something about, well, you can't have moving parts in your pusher. I mean, these are all things we have learned. Oh, amazing. So I simply made a start, did my best. Bob, oh, he just wants to resurrect the shittiest experiments. I mean, go back to his original videos. They're just porn videos, for fuck's sake. He's a fucking 10-year-old. He can't make an argument as a straight up argument. He has to do some sort of buffoonery, dress up in a costume or some kind of nonsense. Anyway, amusingly, back then Gary claimed it was impossible to use a lever to create two different velocities. What a lie. So that's just a silly fucking lie. I mean, so silly. I mean, just an insanely stupid lie. So anyway, so he just, he pushed coins with a lever. Again, the same arguments could be argued about. He had taped up coins. I mean, we're talking about friction. They don't roll straight. All kinds of issues. Absolute garbage as an experiment. Since then, he has had the audacity to claim to be some kind of expert on levers. Well, obviously, I have become quite interested in the subject. And so why don't you point out how I was wrong to point out that, well, the whole fucking, law of the lever is absolute nonsense, because it's really, as a practical fact, you really can't make a lever light enough to do anything significant. And as soon as you give the lever some weight, that's where the problems start. Often relying on that very principle I employed to show that he denied what was happening. So again, just amazing that he would think I didn't understand that how levers work, that I never saw a seesaw, or I never saw a scale balancing. I mean, what an insanely stupid lie. And I'm the one pointing out that it was all about velocity, that all the lever's doing is changing velocities. It's not doing anything else. Okay. Anyway, I'm very glad to see this demonstration show me he was wrong all along. So that's his statement. He put it in capital letters. No, this experiment will prove I'm right. All right. And as soon as Dispar has to do it correctly, okay, it's going to prove me right. Then what are you going to say? Oh, then will you say it finally shows that Brozo was wrong all along? Will you type that in capital letters when the experiment comes out exactly opposite to the current condition? The results will be exactly confirming that it's about the momentum. Alright, P.S. Didn't see, this must be his edit. I did some unrelated experiments fundamentally wrong, and have to thank Mindless Marbles against Hilarious, the imbecile asking the blind, leading the blind, the imbeciles leading the imbeciles, for asking me to look at it again because my results did not match the KE formula theory. My mistake was caused by using a solder sucker as my launching mechanism and not realizing it was self-limited in how fast the spring could launch an object. Well, I don't know about that. It's self-limited by the fact that it's going to have to use some percentage of its energy to move all the crappy, stupid internal parts. This was in relation to how high a 1 mass and a 2 mass would be launched upwards by the same spring force. Oh well, no one's perfect. You're not even close to trying, frankly. I mean, that's the real truth. You're not trying to get right answers. Again, you're just trying to be a thorn in my side. You're trying to be an irritant. And yes, you are successful at doing that. At least I admit when I am wrong, unlike Gary for the most part, whatever that even admits. Where are you admitting any wrongness? I mean, every one of your experiments had theoretically flaws in them, and you haven't acknowledged any of them. You're still saying it's right to dent clay with round objects, that's a linear test. Even though the round object is telling you it's not linear. And he keeps asserting it. It's the right way to do the experiment. That's a quote from last week. How so? Could you draw it and explain how it's the right way to do the experiment? How the round object penetrates the clay the same no matter how far it penetrates? Too stupid. Too dishonest. Alright, so that's the state of things at the moment. And such. So, whatever. Well, let's see what they'll admit to. See if they admit that, yeah, well, if you're going to measure, if you're going to use aggressive friction, just contact friction, no angular momentum, no wheels, no axles, just rubbing friction, that the objects you're comparing should have the same surface contact versus mass ratio. Alright. See if they'll admit that. And then see if they'll admit the other mistake, which again is just plainly detectable with a little bit of thought. And certainly if you draw the experiment, you're going to see it right away. Just draw the experiment. You'll see what's wrong with what he's doing right away. And that's beside the fact that it's a frickin' cardboard carton. I mean, it's a spring, essentially, a crappy spring. You know, so all the other defects in his logic. But anyway, there's a huge underlying defect. Alright, till the next time and such. So forth and whatnot. Do hate this planet.